Hello and welcome to our webinar. My name is Alexander Nikolov and I'm working for Senior GmbH based in Vienna, and we're coordinating the BIOMATDB project. Today's webinar will provide an in-depth look at the biomaterial database, offering tools and insights essential for advancing your research. During this virtual event, you will learn about the BIOMATDB project and its impact on the biomaterials field, explore the comprehensive features of the biomaterial database, watch a live demo tailored for researchers to maximize their use of the platform, and engage in Q&A session to deepen your understanding and address your specific needs. Our today's agenda will start with a short survey aimed at our webinar participants who would like to get to know better. The survey should not take more than 1 minute. The agenda will continue with a short introduction to the BIOMATDB project by our dear colleague, Ms. Celine Rabe. Then our colleagues, Ms. Tilman Carroll from SUNY and Ms. Athena Samara from the University of Oslo will present you the tools and benefits of the biomaterial database. Their presentation will be followed by a live demonstration of the BIOMATDB biomaterial database. The webinar will culminate with an interactive Q&A session, allowing attendees to address their queries directly. So before we continue with our today's agenda, I would like to highlight our today's housekeeping rules. Namely, our virtual event will be recorded and posted on the BIOMATDB project website in order to ensure, according to the rules of open access scientific information, that all collected insights are openly accessible for all interested parties and can support further development activities in the field. Feel free to ask questions anytime with the chat option. We will do our best to answer them during the event. And if you would like to speak after each presentation, please raise your virtual hand. That being said, I would like to invite you to participate in our short survey. Dear Celine, could you please launch the survey? Thank you.
Yes, so as Alexander already mentioned, we would also like to get to know who is participating in this webinar today, and we have prepared a short survey. The survey is completely anonymous, and I will start it now. It will open automatically on the right side of your screen. It may take a few seconds, and then you will be able to see the two questions. The first question is, which category best describes your current position? And if you scroll a bit down, the second question is then, what is your main motivation for exploring the biomaterial database? And you can feel free to select multiple answers for each question. And if the questions have already popped up now on your right side, please start to vote. Yes, I already get the first votes. So feel free to let us know who is participating today and what your motivation is. Perfect, we already have several votes. We have 10 votes. Let's maybe wait a few more seconds as we have a few more participants. Perfect. "15 votes, perfect. Okay, let's say the last 10 seconds, and then I will close the survey and we can quickly see what the results are. So take the last chance and quickly enter your votes and submit it. Okay, so for the first question, I will also shortly stop now the survey, and then I can also share the votes with you. So if you take a look now on the right side, we can see for the first question, which category best describes your current position. A majority of the participants are researchers, but we have also a few medical professionals here and a few procurers of biomaterials or medical devices, and also even an investor and suppliers of manufacturers of biomaterials, and a few have also categorized as other. So I think we have a wide variety of participants today. That's great to see. And if we share then the results of the second question, here the question was, what is the main motivation for exploring the biomaterial database? And here we can see a majority of the participants are interested in the database for research and development, to explore scientific literature on biomaterials for innovation and new technologies, for example. But we also have several persons who are interested because of medical and healthcare purposes. So for example, for reviewing biomaterials research for medical or biomedical applications. And a few of you are also interested for education and teaching purposes, or for industry and business. So that's also really interesting to see that we have also here a lot of different motivations for being interested in the biomaterial database. And then in the next slides or in this webinar, we will also get to know then how the database can cater to these different needs. So thank you very much for participating in this short survey.
Great, thank you guys. So let's move now to the more interesting part of our today's webinar, during which Celine will present you the BIOMATDB project.
Yes, thank you very much, Alexander. So in the following slides, I will introduce to you the BIOMATDB project. And this is the EU-funded project which has led to the development of the biomaterial database, the solution that we are going to explore in detail today. Next slide, please, Alexander. So the BIOMATDB project is funded by the Horizon Europe program, and it is classified as a coordination and support action. The project spans a period of 33 months. It started in June of 2022, and it will end this February. And BIOMATDB brings together 12 partners and 3 subcontractors across 8 European countries, and it is supported by a budget of around 3 million euros. So a central objective of the project is to address the critical challenge of making data on biomaterials accessible and well-structured for relevant practitioners and different user groups. And to tackle this challenge, the main mission of the project was and still is the development of a comprehensive database of biomaterials that includes detailed information on their chemical, physical, biological, and toxicological properties. The database should be accessible to a diverse range of end users, including researchers, companies, and also clinicians. And we have seen also in the survey that a few of these user groups are also present here today. Next slide, please. So as mentioned previously, the project is realized by a consortium of 12 partners from 8 European countries, and the consortium comprises a diverse mix of expertise, including software developers, data engineers, biomaterial institutes, research organizations, and also industry networks and clusters. And we are also supported by biomaterial experts as subcontractors, so by Dr. Osnat Hakimi, by Professor Yannis Misialis, and also by the bioengineer Carla Fuentes Lopez. Next slide, please. So during the duration of the BIOMATDB project, the consortium aimed at fulfilling 5 distinct objectives. And first of all, we wanted to develop an advanced database of biomaterials that provides detailed information on all relevant properties and includes also data analysis and visualization tools. Second, the aim was to launch an information marketplace for suppliers of biomaterials and to implement also digital advisors to support those in need of these materials. And we will post the links to the biomaterial database and the biomaterial marketplace also then in the chat at the end of this presentation. The third aim was to create a label of biocompatibility to define the suitability of biomaterials for use in medical devices or advanced therapies, thereby also boosting the market access for these different biomaterials. And fourth, the aim was to demonstrate the capabilities of the database and the marketplace through different training activities, and also to derive feasible business models for these solutions. The last aim was also to increase awareness and impact of the project through effective and measurable communication and dissemination activities, to make sure that our solutions also gain a wide reach and reach a wide audience. The objectives were really designed also to drive innovation and accessibility in the biomaterials market, and that we also aim to benefit both suppliers and different users of medical devices and biomaterials in the biomaterials field. So next slide, please. After we have now seen the objectives of the BIOMATDB project, I also wanted to show you these two main solutions that came out of the project. So first, we have developed the biomaterial database, which we will also explore in detail during the upcoming segment of this webinar. And this database, as also previously mentioned, provides detailed information on the chemical, physical, biological, and toxicological properties of a wide variety of biomaterials. And it is accessible by a diverse range of end users. And this biomaterial database can be found also under biomaterialdatabase.com. And we will later on also post a link into the chat as mentioned. A second solution that we developed during the project was the Biomaterial Marketplace, which is available at biomaterialmarketplace.com. And this marketplace offers a visual representation of supplier organizations of biomaterials and also their biomaterial products or also services related or relevant in the biomaterials field. The marketplace really focuses on B2B and B2G interactions, and it addresses really the needs of demanders or suppliers such in the field of biomaterials, also including hospitals, medical institutes, universities, or as mentioned, the biomaterials industry and the suppliers of biomaterials. Thank you, Alexander. Next slide, please. So what are the key impacts of these solutions and also of the BIOMATDB project? So first of all, the project will improve access to valuable data and tools by linking external resources and also promoting cross-disciplinary data integration. And this interconnected approach will also enable researchers to harness really a wealth of information about biomaterials. Furthermore, we will introduce advanced text mining, data analysis, visualization tools, and decision support mechanisms. These innovations will empower researchers to conduct precise analyses that can support biomaterials research and development. And by creating these shared biomaterials knowledge bases, we will also enhance the cost effectiveness of research, development, and also of exploitation efforts. Lastly, also on this slide, our extensive data pool, coupled with these advanced analysis and visualization tools, will also provide stakeholders with different insights about biomaterials that can foster or improve informed decision-making and also strategic planning. Next slide, please. Beyond also the data access and research advancements that we want to improve with the project also focuses on raising awareness about the importance of data sharing and also big data among the biomaterials research community and also the industry. And we really therefore aim also to cultivate a culture of collaboration and openness in the field. Furthermore, to support also biomaterial suppliers and particularly SMEs, our project helps really companies to select materials and to navigate also market access and to boost the competitiveness and also growth potential of companies and SMEs. Furthermore, we aim to increase public acceptance of artificial intelligence and related modern technologies through showcasing tangible benefits of AI. And you will see how this is also then connected to the database. And we therefore aim to foster a positive perception and encourage broader adoption of AI and machine learning tools. Lastly, our project will also strengthen the European Union's position as a leader in biomaterials, medical devices, and biomedical engineering, thus ensuring that the EU remains at the forefront of innovation. Next slide, please. On the last slide, you can also see how different user groups and stakeholder groups are really important for the BIOMATDB project. And that is also why we really appreciate that you are also participating in this webinar today. So first of all, enablers such as associations, networks, and initiatives are really important for the project because they support the project's vision and also foster collaboration within the biomaterials community. And their efforts are essential in building also an environment where the knowledge and the resources that were developed in the project are shared or can be shared effectively. Furthermore, the collaboration with suppliers of biomaterials or medical devices and the collaboration with researchers in the biomaterials field is essential for the project because we see suppliers and researchers also as central users of the biomaterial database and marketplace, and we attempt to adapt the solutions, the biomaterial database and marketplace, really exactly to their needs. In the same way, we also see demanders of biomaterials or medical devices as central users of our solution. So, for example, hospitals or medical institutes that utilize these materials for example, patient care or other medical applications. And therefore, we are really interested also in their needs and their feedback. And those feedback rounds that we also conducted throughout the project really informed also our efforts in the development of the biomaterial database and marketplace. And it really helped us to also ensure that the database and marketplace have real-world applicability and can also then benefit the different users. Policymakers, regulators, and investors can also give valuable inputs on how the project can align with industry standards and regulatory requirements. And their guidance is therefore, and feedback is also really helpful in that way to ensure the project's sustainability and growth. And lastly, we of course also want that citizens and patients can, in the end, benefit from the advancements of the project. So all these stakeholders are really important for the BIOMATDB project, and all the stakeholders are really essential to, in the end, ensure that the project can have the expected impact and also the expected success, and that the solutions really are disseminated or reach a wide audience. Thank you very much. That was a short overview of the BIOMATDB project, and I will now hand over to the next speaker to present the biomaterial database.
Yeah, thank you, Celine. Then we can now take the time and go into the actual database. We will start with, on the next slide, please, with a few key advantages of the database, some general ones. So the main thing that we can provide, or the database can provide, is the general enhanced search functionality. So Celine already mentioned it. We use these machine learning and AI algorithms, which are powered by annotations by multidisciplinary experts. So we bring a lot of expertise in here, which then also serves in a way as this quality assurance that we have. This is all packed in a, I would say, yes, a user-friendly interface that we will explore in a second. And one also important component that we have are these visual analytics, visual analytic components and analysis visualization that we can use, or that you can use to get better insights based on the search queries, on the search filters you set. Further points that the database provides are like these convenience features that you also have for other databases. You can generate, for example, bulk citations or single citation of publications you find. You get a PDF export either of the publications you find or of the visualizations. You then generate and modify, and also have some other features that we will explore in a second. But for now, let's look at the database itself with a few screenshots. On the next slide, please. We can see, yeah, how the database looks. We will get a closer look once we have the live demonstration in a second. So we have the main search, and what you can see, we have a very clear presentation of the results. We have this highlighting of the matched keywords. And if you go to the next slide, please. Yeah, we can get a closer look of the keyword matching. For example, this particular search we search for titanium, and then we also have this detail page, which also then opens up in a new tab where you can then get further information about this particular publication. But I guess in the live demonstration, it will be more clear. On the next slide, please, we can see. Oh, maybe let's put it the other way around. These different filters that you will see in a second, the advanced ones, the basic ones, are all or most of them are rooted in the mesh terms and this general metadata tree and structure that maybe Athena will talk about a bit more if you have questions on that. But so the filters are also rooted in something very concrete. Next step, please. Or Athena, if you want to mention something here, then.
No, just to say maybe that mesh terms and substance terms are a way to go beyond keyword search and actually show that we have managed to use a structured vocabulary, not only to build this database, but also to set a foundation for anyone else that wants to go beyond this project. So this is what we had identified, that what is missing is a structured way to categorize and index all the data for biomaterials. And we did it using the medical headings of as they are on, at the NLP library. So the mesh terms and the substance terms we use are essentially a very complicated dictionary. And this is how we plan to proceed in order to visualize this at the front end as well with the advanced filters that Kilman mentioned. But we can take this afterwards at the live version, right?
Yes, thank you very much. Maybe we can go to the next slide. Here we can an example of how these search results will then be visualized here on the right-hand side. But I guess, as you mentioned, Athena, it's better to look at this with a live demonstration, then we have enough time and can also play around a bit with these visualizations. And if we go then to the next slide, then we can see that we can also these different visualizations that we have on the left-hand side. We will see them in a second. And we can also then generate this report I mentioned that you will see in a second as well. So I guess we can now, if you go to the next slide, already go into the live demonstration. I had this screenshot we will also see then in the live demonstration. I think that's easier for now. And I would now share my screen. And wait a second. Okay, now okay, I'm back. It just froze for a second. Okay, you now should be able to see my screen.
We can see it.
Perfect. Okay, what you can see here now, what you already saw in the screenshots, is the start page of the biomaterial database. And it features very prominently the search bar that we will use in a second. What we also have here are a few fast filters. For example, you can search by sex or study type. We also prepared a few case studies which go into different personas and walk you through some of the functionalities and case studies you can use the database for. We will not do this in a moment, but if you want to explore the database on your own, this is a good way to start and kind of get a feel of what filters are there and also what possibilities or what ways you can use the database in and for. What we also have here are a few quick links. For example, if you want to get to know more about the consortium that Celine presented, we also linked one of the papers that has been written as part of this project, where the partners talk about redefining biomaterial biocompatibility and also the marketplace that Celine mentioned. Before we get into the database more, we also have, next to the database itself, additional resources, so additional literature, additional projects and events which are related to biomaterials, but are not part of the actual database, and is, as mentioned, more of an additional resource. We have them, for example, here on the right-hand side, a few events related to biomaterials. You can maybe quickly open them, and then you can here also filter, for example, for workshops and conferences and so on. So this is rather an additional module that you cannot search for in the search bar, just mentioned at the beginning. Athena, do you want to add something?
Yes.
Please.
So first of all this information that we are discussing about mesh terms and substance terms is available on the help section.
Yes.
And the diagram that Tilman presented and how we went from identifying what is missing to actually combining mesh terms under specific BIOMATDB labels, as we call them, and what each category entails. So all this is there in lay terms, we hope, and it should make your life easier when you go through the advanced filters. But if we go back to the front page, we have 5 case studies there, and these were identified as we did an internal survey that we then bounced with an external survey to identify whether we know what kind of users will go through the database. So we have a biochemist persona or a tissue engineering persona. So we tried to make simple and more advanced scenarios of how people would go about the database. And we put this up there as a first exploration option. And then you have the help section for users to see what else they can do with the database beyond this. And
yeah, thank you. Very good point. The help section or the help system you can access anytime here in the navigation bar when you click on help system, and then the help system itself will open up. I will not present this anymore or in more detail, but yeah, you can search for specific articles or FAQs or simply go through all the different articles that we have prepared, which should guide and help you through the process of exploring the database on your own. What you will also see at the bottom of every page is this help icon. And if you click on the help icon, you can go, for most of the pages, we have this dedicated help article. We can go to the related help article, which will open up here, for example, the homepage components. That's a page that we were on. And this page then details all the different things you can do and explain a bit more the advanced filters and what you can actually do and see on this page. So this can always be accessed on the bottom right, which I guess is also a good thing if you explore the database on your own. We also have prepared these guided tours. So I can also start a tour and then I will be guided through this page interactively. Also something that might be interesting for you to explore on your own. I prepared a few searches for now to explore, and I already opened up one where we search for pregnancy and medical device. Maybe I can also do it again. If I type in here in the search articles on biomaterials in this input field, I can type in basically any keywords that I want. I can concatenate them with and or, and a few other operators that are also described in the help system. But for now, let's just do this very simple search. And as you see, we kind of quickly get 49 results out of. Right now, we have about 3 to 4 million publications in the database. And until the end of the project, it will expand to around 35 to 40 million. So quite a lot. And what we can see here now are the results for this or these search terms, and we can see a lot is happening. And I will now go through the different things that you can see here. A few things that haven't changed is the search bar. We also saw this on the start page. Then we have these fast filters here, which if I click on something, it will be applied kind of instant. I will go into more detail about what these do in a second. What I can also do, I can change the attribute by which I'm sorting. I can change the sorting direction, and can also, for example, share my search. If I have the search and I want to share it with a colleague, with a fellow researcher, then I can click share search and then open up a new tab and would be redirected to this exact same search that I have open. Okay, one crucial thing that we have here, or one kind of important thing that maybe also be, not too easy to understand or not too intuitive at the beginning, is this ranking score. And I guess what is important here is that this ranking score is, as we also have this kind of little information here for you to always kind of check upon again what this is a value that's assigned to each item that we have here in the search results. And this ranking score quantifies how good this particular result item matches our keyword query here that we have and the filters that we have set here in the fast filters or maybe even in the advanced filters. So all these are being considered, and then a ranking score is being returned. And the higher the ranking score, this is kind of obvious, I would say, the better the system thinks this result matches your general query. What we can also do if you want to explore a little bit about this ranking score, we have here for every publication a few options. We can click on explain, and then we see how much different aspects contribute to the score to give a little bit more of an understanding, maybe what aspects influence this ranking. What we can also see here that some of these are highlighted, and for example, in this very first result, only device is highlighted. That's because we search here or by default in the title and the abstract. And now we can see here in the abstract as well the medical device and pregnancy being highlighted. A few other core features that I want to explain or show you is this cite button, where you can easily export the citation for any publications that you have. You can also save publications if you are logged in into a collection. And then we can, I already have it open. We have this collection here where now 2 publications are saved in main collection. And from here on, I can also cite this publication, remove it, and kind of group publications based on the interest I have in them. Maybe I have a certain research proposal or I have a class that I'm preparing. So this might be also a cool feature for you to explore. One thing that we can also do is if we select multiple publications here, we can also select all on the page. But for now, let's just select maybe the top 5. So 3, 4, 5, because we are now interested in them. We can also export the citations for all of them, but we can also download the data and then specify a few options here. For example, we can use PDF, CSV, or JSON. For now, let's just use a JSON export, but PDF also works here just for these files. For these publications, we can download it, and if we open it, we are then, sorry. We can then also inspect this these exports. Okay, a few more things that might be interesting here, just functionality-wise at the beginning. We already talked about sharing a search. What you can also do if you don't want to keep a list somewhere else to save your searches basically and come back to them later, you can also save them search directly here in the database. And if you do that, then the searches will be displayed, for example, like this here under your profile, and then you can go back to the search at any time. And if you would set more filters, then these would also be displayed here. This collection I mentioned and the searches can also be accessed over the top right when you click on your profile name. Mine is now Tilman Kerl. And then you can go to my collection and my searches. Okay, I guess these are the core features that we have here on this start page, on the search results page. Before we continue, maybe one quick look at the details page where we have the entire abstract. We already saved this to our collection, so we can remove it if we want here. we can, of course, again, do the citation. And if we are on a detail page, we can also inspect all the associated mesh terms to this particular publication. For example, here we have middle-aged, Pennsylvania, pregnancy, and so on. We can also then go to the National Library of Medicine and to get the exact definitions here and the metadata tree for these particular ones. Okay, now we are back at the search results page, and I think, Athena, you wanted to mention something.
Do you want to maybe explain the difference when we click on PubMed, PMC, and biomaterial journals only relative to the mesh terms?
Yes, this is a good point. So PubMed, so we have two main data sources at the moment, and this is still being processed while we speak. PubMed is the main data source for which we have all the AI-powered annotations and classifications that you can use to explore your search, to go more into detail. For PMC, we are still in the process of harvesting and classifying them and processing them. So right now, if you select PMC, you have a lot more results. For example, now we have 178, but some of these filters are not working right now because we haven't processed all of the data in PMC yet. One interesting thing here is also the biomaterials journal only, which relates to the data source itself. And if we click this, then we wait a second, and now we have only 3 results, because what this filter is doing is it restricts the search to only show publications which are in dedicated or in particular journals related only to biomaterials, and then also ranks these publications higher. So if a journal is related or has a relatedness score, let's say, of 0.9 out of 1, then this publication would be ranked higher than if a publication belongs to a journal where the relatedness score is only 0.5, for example. So this is what this one is doing. And if you want to have like a more focused search on particular biomaterial journals, this is a good way to start and already a good way to narrow down your search results, because now we had 49 before out of a few million. Now we have only 3. Which is quite a big difference, I would say. Yeah, we also have these other filters, which I guess is also interesting if you just want to explore them on your own. But maybe one thing that's interesting, if we have, for example, sex here, and pregnancy typically related rather to females, I would say. And this also shows if we select male, then only 5 results are in a way related to male. You would now need to inspect them further and see why they are actually related to male. And but if we unselect this and select female, then we see, okay, 42, it's basically all of them, which also, at least from my perspective, is intuitively makes sense. Okay, I would say we can then go and have a look at the first visualization that we have here before we get into the more interesting ones. Maybe you already saw the publications over time visualization on the right. You could use this to filter, for example, and now we only have publications starting from around 2004. And I can then reset again, and you might think maybe it's not too easy to filter with this. Then you can also expand the graph, have a a bigger version of this, and can filter more precisely here if you want, or can also export this graph or take a screenshot if you want to use it in a proposal, a report, or anything else. I would say we can now go to the very interesting part. So for our search that we have right now, the pregnancy and medical device, we can now visualize the associations. This can be done if we click here on the right-hand side on click to visualize associations. And what this is doing, I just already opened it. It opens up this new tab where we are visualizing the associations. And by default, because we have this very, very large database of multiple millions of results, we take by default the top 500 and the top 250 hits of the search you performed. So in our case, we search for pregnancy and medical device. So it would take by default the first 250 results and analyze them. Right now, we only have 49 results. So it analyzes these 49. But if we would have, for example, a very generic query like dopamine or just titanium, then we would get tens and thousands of results, and then, yeah, we would only take the first 250. You can also change this amount, but there's a limit to 500 to, to just keep the computation times and the loading times like reasonable, because that's quite a lot of computation that is being done in the back. Because what we can see here right now is the co-occurrence of the top 10 mesh terms. And here we have two different kind of concepts. First of all, the frequent mesh terms, which just look at the absolute count of the most frequent mesh terms within these top n, in our case, in these 49 publications. That is being displayed here on the left. And then we have the relevant mesh terms. Well, relevancy is a metric or a concept in this context, which looks at how often this or these particular mesh terms occur in this subset that we have and compare them to the entire database. So a relevant mesh term here in this publication, a relevant mesh term here for the subset will probably not be relevant for another subset. We have two variations of this co-occurrence plot. So we have first this node link diagram, and I will go into more detail about this in a second. And I think Athena can also then add something here. But if we scroll down a bit, we can switch between the different visualizations, and the same information is also displayed, for example, as a heat map. And then we have also an embedding scatter plot that we'll go into in a second. But maybe let's go back to the co-occurrence here in the node link diagram. And what I already did, so if I double click on a node, then we can see that the publications have been updated. And now in the publications tab here below, we see the subset of publications that have this particular mesh term associated with them. So what we have here is, please excuse my pronunciation, is levonorgestrel, which I opened it up for you in case you might not be familiar with it, is a drug basically used to prevent pregnancy after unprotected sexual intercourse, which, as I'm no biomedical or biomaterial expert, is already interesting that we find it here, and without specifying something, we find this very important and I would say prominent drug for obviously pregnancy and medical device, which is very much related. And what you can see on the right-hand side is, of course, a little bit more of a description. And we can then again go, because this is then a mesh term, to the National Library of Medicine. This page is always a bit slow and can then inspect all the different entry terms and registry numbers and so on if we want to dive deeper more into this aspect. Yeah. Athena, do you want to mention something here now for this example?
Yes. So basically, we chose this example that seems totally out of the box because this is a biomaterial database. And but you might be a non-expert. You might be someone that's not even related to the field of biomaterials per se. But you might be a gynecologist and you want to try out what this database can do for you, because this is what we advertise, that we're basing the search on mesh terms. So if mesh terms work, they should help you to do a search that is totally irrelevant to what the title of the database is. So if you're a non-expert, but you're a gynecologist, you would go with a term like pregnancy or gestation and medical device, because this is what we advertise that we do, biomaterials and medical device search. So you do a simple, irrelevant Boolean search with pregnancy and medical device. You click on the associations, and what you find is actual medical conditions, medical devices related to pregnancy, and even drugs. So considering that drugs are mesh terms and substance terms as well, and you also get the type of material, like there's copper somewhere, for example. There are terms like pelvic inflammatory disease, which is a medical condition. And considering that the database is almost finalized, both at the level of integrating abstracts, which is happening in iterations and as we speak, and also considering that we will have a biocompatibility assessment tab that is not active now because things are still happening, then by clicking on associations in the future at the end of the project, you will be able to have a clearer idea, not only for the medical devices, but also you will categorize these under adverse effects, or you will see whether this is a chronic issue or something that might come up on the first 10 days after material issue association. So this kind of example is to show that this database can facilitate hypothesis-driven search. Because if, as Tilman showed you, if you go to the actual drug or medical condition and click on it, you can actually visualize only the abstracts that relate to the papers that describe pregnancy, medical device, and that specific medical condition or drug that has been used. So for us, that was one of the aims of the database, to facilitate not only simple unsupervised or advanced unsupervised search, and to have a backend that encapsulates all this mesh term effort by multidisciplinary experts, but also to show that you can do any search that will lead you to hypothesis-driven, non-waste of time. So we can also do the other example with something like heart, as we were discussing, just another one out of the box that is relevant to the classic, titanium and nano stuff. Yeah.
Yeah. So this is the other example that I prepared. So this is now we search for, maybe I can go back here. This is the main search page, as you know it. And here we search for heart and valve and scaffolds. And then again, I click to visualize associations. And again, we have the co-occurrence here in this node link diagram. We again have the heat map, and we have this embedding plot. And maybe I can now talk a bit about, in this example, about the heat maps that we have, because these heat maps offer a few different interactivity elements that the node link diagram does not have. What we still can do is we can hover here, for example, over, if we look at animals and swine, so again, the co-occurrence between these two, or cells cultured and humans, and then we have 30 publications, and if we click on this, then we get again the 30 publications where these two co-occur, which can also help us narrow down the publication that we're actually interested in. We have this again for the frequent mesh terms and the relevant mesh terms. So this is again the same concepts we talked about before. And what you can also do here for this heat map is then filter these different aspects by, for example, toxicity aspects. In this case, there are none in the top 10. We can also do, for example, look at manufactured products and, for example, bioactive compounds. And like this, filter down our visualization to help you get the most out of it and the most interesting part that actually interests you. For example, if you're just interested in model system and maybe compare the relevant model system terms with the frequent model system terms, then you can see, are there differences, are there none? And can also then lead you to maybe interesting publications. One other visualization that we haven't talked about yet is this embedding scatter plot. And what this kind of tries is to help or give you a tool that can identify potentially new interesting publications that you wouldn't have considered. Because what we had in the original search is we would have these 250 first results, and normally maybe you look at the first 10 or 50 or so. What this is doing, each of these dots represents one publication, and using some advanced NLP techniques, I can also go into detail about this. It's particularly a fine-tuned BERT model. We can now plot these different publications in this two-dimensional space, and the distance between these publications kind of resemble their semantic similarity. So these two publications here, for example, are kind of similar, whereas this publication in the top left is not very similar to the publication on the bottom right. The color here is then the ranking score the system assigned to every publication, meaning that publications which are colored, for example, yellow, let's say this one, I can click on it and I'll have it here on the right-hand side open, indicates that the system thinks, oh, this is a very relevant result given our query, in this case, hard and valve and scaffolds. But for example, this one here, the dark one at the bottom, the system thinks might not be as relevant to your search. However, semantically, they are, or they seem to be similar. So what this visualization or this tool can help you with is maybe encouraged to also explore maybe this publications, which you normally probably would not have tried out or looked at because it only has the score of 13, where the maximum ranking score is already 26. And then you can again go to the detail page of this publication. You can do the usual stuff like citation if you want to explore it in more detail further. And one thing that you can also do here, if you have these 250 publications, you can also filter them, for example, by the PubMed ID. So you can do a hashtag, the PubMed ID, and then the particular publication is being opened and highlighted. What you can also do is to do a text search. For example, I type in cell. I mean, a lot of them contain the word cell, but then you have all the different publications that contain the word cell as well. Oh, sorry, and then I can again do this. This visualization might be a bit difficult, or maybe has a lot to offer and the different certain layers to it. Again, we have here a short description for this. You can even go a little bit more into detail about what are text embeddings and how is text similarity measured here. And again, we also have this related help page for the related help page for the search insights components, where we go into detail about all the different aspects and again about what this embedding scatter plot can do, and also the other visualizations that we have talked about. Before we maybe can, let's have a look at the time. Okay, maybe one thing before Athena can say a few more things concerning what you can actually see. Last functionality is the export, where we can export the different visualizations that we have. For example, the publications over time, the frequent mesh terms, and so on. Let's just select all of them. And now our report is being processed and already ready to download. And now we can open it. And this is then the visualizations that we can export. Yeah. So this would be the main things functionality-wise. Athena, do you want to mention a few more things concerning this example, or do you want to go also to another example? You're muted.
I'm muted. Can you also try one more example from the gynecology field once again? That we will not even mention medical device or biomaterials. So if you just go and try exactly pregnancy and gestational diabetes, right?
And then,
and you only click on PubMed, then if you go
PubMed, sorry, yeah,
only PubMed, right? Then we have 1,000, almost 1,700 results. Click to visualize. and then they're on the relevant mesh terms, right?
Yeah.
Without even having incorporated the biocompatibility assessment function yet, we can see that what we see on the relevant mesh terms is fetal macrosomia, and then pregnancy in diabetics, pregnancy outcome, gestational weight gain. So most of them are actually very interesting for gynecologists. Once again, that was the example, because they relate to adverse pregnancy outcomes or terms that will relate to adverse pregnancy outcomes. So these mesh terms are actually real red flags for clinicians. So this is the success story of the database. It goes beyond just biomaterials. You don't even need to type biomaterials at that level because the relevant mesh terms might be interesting on their own. And of course, we have to say that you can always pick one of these relevant mesh terms and go back to your actual search and refine your search by using the relevant mesh terms. Like the previous example with the heart valve and the scaffolds is one of these cases that if you start with, if you go to the other one, hypertension, for example, right? So if you search for this, we have only 12 results, right?
Mm-hmm.
But if you click on associations,
Yep, this is this one. Yeah.
Yeah. So that is a very specific example because it's scaffolds, right? So we still find everolimus, which is a drug. So even if you have 12 results, right, you can still get something. So it's always useful to click on the associations because it goes, because a lot of people will say that, I mean, you will never get better than PubMed. I've heard this story, and PubMed is there, etc. But we never wanted to be PubMed. We wanted to step on PubMed and make a better success story and actually build on it and use it to do hypothesis-driven search instead of just looking at the index. Because basically, we also index all relevant abstracts on the front end, but we visualize the associations on this in the insights that we show there. And at the same time, unlike PubMed, we don't only go via keywords. We can do better and actually help people to build on the abstract and the relevant papers that they need when they want to do systematic review, for example. Sorry, they're drilling here in like after a week. And so if you go again to the scatter plot.
Here we don't have enough data. Let's do this scatter plot.
We can go to any, right? So again, there is no way that we can actually get this clustering ourselves because people say that we use 10% of our brain, right? Even if we use 20, we wouldn't manage to cluster everything that PubMed has this way because we cannot process these terms in that way. So it is really worth it and to go with your own specific paper of interest and type in the PubMed ID, for example, and see where it fits in this cluster and what other papers are relevant to your own research. So beyond looking at authors that have contributed to papers, you can even find your own niche in these clusters. So, I mean, other than facilitating research, it helps your own neighbor if you want to.
Yeah.
There we are.
Thanks a lot for the insight as well. I think this then also concludes the demonstration for the database itself. And we can now go over over to the next step, and I would stop sharing here. Wait, okay, I cannot stop sharing. Here on the right, sorry. It moved. And then we can now go over to the FAQ section.
Yes, also before we jump into the Q&A, I will
Q&A.
post now all the links that are relevant for you into the chat. You find the chat with the speech bubble symbol on the right side of WebEx. And you will find here now the links, first of all, to the biomaterial database. Then you find the link also to the biomaterial marketplace, our second solution. Then also the links to feedback surveys, because we are currently also always trying to improve our solutions. So you find those also here if you have some feedback for us after you have checked them out. And also all the relevant links to the BIOMATDB project. And they're all posted in one message. So I would recommend to really just go to this speech bubble symbol and to copy the whole message. Then you can check out the biomaterial database and also our other solutions and links after this call. Thank you.
Yeah, thank you, Celine. So now is the time for you to ask questions if you have any, either by unmuting yourself or writing to the chat. Yeah, feel free. Now is the time.
Speak now or forever be silent.
Okay, we have one comment in the chat. A really fun one with, I appreciate the typos in the search, but otherwise I think, yeah, we wanted to keep it realistic, of course. But if there are no other questions at the moment, or maybe you still need a little bit time to think about it, Tim and I maybe have a question, because that was a lot of information now. What if I'm a bit unsure how everything works, or if I want to show the database to some of my colleagues? Are there any tools available where I can look up all the information, or where I can find some further help tools or something like that?
Yes, this is the, or you can find all the related information on the help system of the biomaterial database. So this is then help.biomaterialdatabase.com, and this is also in the navigation bar of the website itself. So there are all these help articles explaining the different components, the different search filters, the general functionality of the site, the different visualizations, and so on. So I guess this is the first resource to go to. And Athena also mentioned it. We try to narrow down or explain everything in a way that it can be understood. Also the different mesh terms, or the approach of the mesh terms that has been mentioned. And I already see one question in the chat that I could answer now from Veronica. Could you please repeat the differences between PubMed and this database? So maybe I can start with this, and then Athena, if I forget something, you can jump in. One of the main differences, I would say, is that we have here this concentration, or this focus on biomaterials itself. We went through, or experts and other technical partners went through an extensive process of looking at and annotating a lot of data, and establishing different classifications of or grouping of, for example, mesh terms of publications. And these different aspects can be used to then, we quickly highlighted, for example, the biomaterials only, which is one result of this. And also these advanced filters, we didn't go into a lot of detail now, but you can also have a look at the help system here. And with these filters, the database allows you in contrary to PubMed, to do a lot more specialized search. So the search itself is different, and maybe also this hypothesis-driven search, as Tina mentioned, and maybe she can also say a few more things about this. But this would be the one thing, the specialized search, like generally speaking. Second of all, we have all these different visualizations and analysis aspects or visual analytics components that can help you deepen your search and kind of identify different aspects for you. So kind of more things that we build upon this. We want to maybe, let's say, get step on PubMed and say, okay, we can provide more here. And Athena, maybe did I miss something?
No, but I think I understand the question differently. So first of all, when you go to Pub, I don't know if you're in research or not, but obviously if you are, or you're doing searches on PubMed, you know that there are some journals relative to biomaterials that exactly PubMed. Okay. So there are some journals relative to biomaterials that are not indexed on PubMed. So you will have to do different searches, or you need to go to the actual journal. And if you go to the journal, then it is just an index, and it has nothing to do with mesh term categorization or under your search. So let's say you want to look for, I don't know, PEG and titanium nanoparticles, right? It could be that it could be that you have 1,000 results. They're also based on mesh terms. There is nothing else to do on PubMed other than download, right? Or do a more advanced search based on more defined mesh terms, etc. Here, what we have done is take it to the next level. So one, we have included the journals relevant to biomaterials. Two, we are actually curating the data at a different level, both at the front end by choosing the mesh terms. So you can actually click on the advanced search and choose what you want to identify, whether that is the model system, whether it's in vitro, in vivo, or whether it's a prospective study or a clinical trial. So you can filter at the front end, and you can cluster at the same time on the visualization insight on a separate page. So instead of just getting a list of publications based on the search, we have borrowed ideas from String and other bioinformatics tools, and we're visualizing these data. So we're bringing the back end a step closer to the front end, basically. We are clustering the data differently in order for you to do a hypothesis-driven search, whether you're an expert on how to do advanced searches on PubMed or not, because the visualization is the key to doing better searches in this case. I hope I covered it, but of course you can ask more.
Yeah, I think for now we have a good answer on this, but yeah, of course, feel free to ask a second for a follow-up question. The next question that I see here, I think Celine, you can answer this.
Yes, sure. So the next question is how the biomaterial marketplace, in this case, is updating new products or medical devices. Do you need data to be sent by a manufacturer, for example? So yes, that is correct. So everyone or every biomaterial supplier can register on the biomaterial marketplace. So you can go to biomaterialmarketplace.com, scroll down, click on sign up, and then you can sign in as a biomaterial supplier, and you can then upload your organization profile and also your products and its specifications, or also any services that you're offering. You can also upload any for example, product brochures or also upcoming events or news. So yes, the biomaterial marketplace, the suppliers provide the information about their products themselves. What we can do is we can offer also some selective support for entering all the information. So if you are interested in signing up for the marketplace, then you can also reach out to us via the project email address, which is we can also post in the chat, which is office@biomatdb.eu. Here you can also reach out to us if you have any questions, or also via the contact form on the marketplace. And we can then discuss if there are any also support options for entering the data. But yes, in principle, it's really simple to do. You have the administration panel for the suppliers where they can enter their data about their products, medical devices or services. And the marketplace is also really not only directed towards suppliers of novel biomaterials or also biomaterials they offer, but also towards, for example, projects that are working on developing new or novel biomaterials or medical devices. So you can also register there on the marketplace. But of course, yes, the primary user that we envision also for the marketplace are suppliers that are offering their products or services there. I hope that answers your question. Otherwise, please let me know also in the chat or simply raise your hand.
Okay, that looks good, I would say.
That looks good, yes.
Are there more questions right now? How you load articles on the platform. This is a long process. Let's put it like this. Okay, how do I best describe it? So we have so what we saw in the live demonstration is kind of the front end, this web application with which you can query and access the actual database, the technical product database in the back. And this technical, or this actual database in the back is being populated programmatically. So the other technical partners extracted and downloaded and processed and are still processing these millions of articles, partially from PubMed or mostly here from PubMed. Then we also have this other data source, PMC. They aggregate all this data, they process it, and then they programmatically, with the added information, the added metadata, then programmatically insert this data into the actual database. What we use is an Elasticsearch database. I don't know if this is interesting or database. And then what we do on the front end and what you can actually see is then access this and then only get the relevant parts for your specific query into the platform, the front end platform. I don't know if this answered the question. There are also some public deliverables from this project, which go into a bit more detail in this entire process. I think that these are also public. You can find them on the project website itself, which is biomatdb.eu. And then, yeah, there's some more information on this entire process.
Is this a technical question? Is it about the integration of data?
Okay, I guess it's a bit of a technical question. No, we don't need for a user to actively send us the article. Right now, it might be that some articles are not on the platform, or you might not find yourself there because we haven't processed all the data yet. So there are still a few million missing that are being processed right now. And no, don't worry. So this might be a reason why you maybe will not find a certain article that you're looking for. But no, so this happens all automatically. Once an article has been published, then we will find it if it is related to biomaterials.
Yep. So basically, don't find us, we'll find you. If it's somewhere visible And we don't even need open the full article. We are curating abstracts.
Mm-hmm.
So if your abstract is on a biomaterial journal, and if it's on or on PubMed or PMC, which makes it open, of course, if it can be PMC, then it will think of it as fishing for words. So if the right words are there, we'll pick them, and then we will recategorize them under these specific labels. So it's a bit of mingling of words and restructuring them and re-visualizing them the way we want to. So if it's out there, and then the plan was to include also clinical trial and patent data and electronic health records. So the idea is to reutilize publicly available data to make a very comprehensive database. Does that help?
Looks like it. Glad we could clear this up.
And also, I posted in the chat the link to our project website where you can find then all the public deliverables that are published during the project. And here you can also find more technical background and detailed information about how this whole process is working. Not all of the public deliverables are uploaded yet. The second batch of public deliverables will then be uploaded to the website in March. So in case you're interested, then also for the further ones.
Plus, we plan to, at some point, have all the code submitted to a journal, and each part of the database will be written as a small paper or a large paper. So all this work will be at the end published as articles. So it will be, better described.
Any other questions? We have still a few minutes left in the webinar. Or feedback, I don't know. Yeah, Alexander, I think it looks good so far.
All right.
No further questions.
All right, so thank you everyone for participating in our today's webinar. We hope that you enjoyed it and it was really informative for you. So don't forget to check online the biomaterial database. And if you have questions, please feel free to reach out to us anytime. We also kindly invite you to follow us on our social media channels, get in touch with us via our project website, and to discuss further collaboration opportunities with us, Senio, or any partner from our consortium, please also feel free to get in touch via office@biomatdb.eu. Thank you very much for joining us today and wish you a nice rest of the day. Thank you, guys.